Now let us take the case for your s orbital. Now look here, for s orbital your given n value is 1. So let us try to recall the formula. What happens? N value is 1, that is your principal quantum number is 1. So how we will find your angular quantum number? L equal to n minus 1, that is 1 minus 1, that is 0. Okay, so this is the thing that you have to remember. They have given principal quantum number for s orbital is taken as 1. So L, that is angular quantum number for s orbital, is given equal to n minus 1, that is 1 minus 1 equal to 0. Now try to recall the magnetic quantum number. It was having the formula of plus L to minus L. So what we will write here, the L is 0, so M will take up only 0 value. It means what? Your s orbital is one-fold degenerate. It means your s orbital is one-fold degenerate. Therefore your s orbital can take up maximum 2 electrons. And you can write down the shape here, that is shape of the s orbital is spherical. So you can draw it just like a sphere. This sphere is having uniform distribution of electrons in all the sides. Now taking the case of the p orbital. What happens? For given value of principal quantum number n equal to 2, again we will use those formulas. Your angular quantum number L will be equal to n minus 1, that is 2 minus 1 equal to 1. Now what was our formula? Magnetic quantum number M was formulated as plus L to minus L. So what we will do is, look here, L is having 1 value, so we will go from plus L to minus L. It means plus 1, 0 and minus 1 values M can take up. Therefore you can write that p orbital is threefold degenerate. P orbital is threefold degenerate. So what we can say, it can take up 6 maximum electrons. Now how to draw the shape of different p orbitals? Let us try to draw the shapes of p orbitals. In case of drawing the shapes, what we can do is, like you have, first of all we will draw the axis like that of graph. This is your y-axis, this is your x-axis and this is your z-axis. So what we will do is, when we are trying to draw px orbital, it means your dumbbell will lie on this x axis. Okay, so px orbital, your dumbbell shape will lie on this x-axis line, and whenever we are trying to draw for the y or py case, then again y, x, z. It means for py case you can put your dumbbell on your y axis. Same thing you can draw here for the case of the pz, that is again this is your y, this is your x, this is your z. For pz case you can draw a dumbbell on this z axis. So it is clear that shape of the p orbital is dumbbell. Okay, that is the thing that one has to remember while discussing the case of the orbitals. Now we will move to the third part, that is third is d orbitals. Now similarly we will try to again calculate all the quantum numbers for your d orbital, that is for given n equal to 3, that is your principal quantum number for the d orbital is n equal to 3. So what we will do, try to recall the formula, that is L was having the formula of n minus 1, that is 3 minus 1 equal to 2, right? Then you have to calculate m, that is your magnetic quantum number, that can take up the value from plus L to minus L. So what happens is your m, you can write here, you are aware that it is having 2 value. So you can start writing plus 2, plus 1, 0, minus 1, minus 2. It means what? Your d orbital is 5-fold degenerate. It is having 5-fold degeneracy, and therefore your d orbital can take up maximum 10 electrons. These things you have to remember. Again you can see the shape as complex shape, so we are not taking into detail, but your d case and f orbital case are having the complex shape. Now let us try to move to the fourth case, that is your f orbital. Now for the f orbital, you are given principal quantum number n equal to 4. Okay, so your n equal to 4 means your principal quantum number is having the value of your 4. It means if I want to find out the angular quantum number or azimuthal quantum number, what is the formula? L equal to n minus 1, that is you can write here the case, that is 4 minus 1, that is 3. Now you are already aware of the magnetic quantum number, that is taking the value equal to plus L to minus L. So what will happen? You can calculate the m as plus 3 plus 2 plus 1 0 minus 1 minus 2 minus 3. So here for the given principal quantum number value n equal to 4, your L, that is angular quantum number, takes up the value equal to 3. Your m, that is magnetic quantum number, is going to take up the value from plus 3 to minus 3 including your 0. Therefore we can write here that your f orbital is 7-fold degenerate. So how many electrons it can take up? That is your f orbital can take up 14 electrons into it. And again, as discussed, the shape is complex and it will take up the 14 electrons to the maximum limit. Again we will try to recollect all the 4 cases, that is we can see here for the s orbital case we have calculated that n is given to be 1, that is principal quantum number was given 1. So L value that will turn out to be n minus 1, that means it is your principal quantum number minus 1, it means it is 1 minus 1, that turns out to be 0. Now if you want to find out m, that is magnetic quantum number, it will take up the value equal to plus L to minus L, but here as the L value is 0, so again your magnetic quantum number turns out to be 0. Now as you are aware, it is having only single value, so your s orbital is basically 1-fold degenerate. Now S orbital can maximum take up to 2 electrons, and the shape of the S orbital is spherical, that one has to remember. While writing all the short notes, one has to describe all the quantum numbers into detail and find out the shape with the drawings. Second case that we will take up, that is your p orbital case, that is your n value, that is principal quantum number value, is given to be 2. Your L value, that is n minus 1, is equal to be 1. That means your principal quantum number is 2, your angular quantum number or azimuthal quantum number is equal to your 1. And from that, your magnetic quantum number comes out to be plus L to minus L, that is plus 1, 0 and minus 1. It means it can take up to 3 values, and that's why your p orbital is basically 3-fold degenerate. And due to this, your p orbital can accommodate maximum 6 electrons into it. Regarding the d orbital case, you can see here your principal quantum number value is n equal to 3. So your L is equal to 3 minus 1, that is 2, and your m, that is magnetic quantum number, will take up the values from plus 2, plus 1, 0, minus 1 and minus 2. That means your magnetic quantum numbers can take up the value up to 5, and that's why your d orbital is basically 5-fold degenerate, and d orbital can take up the 10 electrons to the maximum limits. Coming to the case for the f orbital, we can see here that the principal quantum number value for the f orbital is n equal to 4. Therefore, your angular quantum number equal to n minus 1, that is 4 minus 1 equal to 3, and therefore your m can take up the value from plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3, and therefore your f orbital is basically 7-fold degenerate. And similarly, your f orbital can take up the maximum, that is up to 14 electrons with a complex shape. Now let us try to recollect certain rules, that is Aufbau rule, or you can say Aufbau principle. Now what is the meaning of this Aufbau? It is basically a German word that means construction, right? Now this principle is basically stating that it states electrons enters into lowest energy orbital first, and then higher energy orbitals are gradually filled. It means what? Your electron is basically entering into the orbital which have the lowest energy, and after that higher energy orbitals are going to get filled. Okay, for that Aufbau has given one sequence of the different orbitals, and from that orbital we can calculate the so many things. That is, you can write here the sequences: your 1s orbital less than 2s, less than 2p, less than 3s, less than 3p, less than 4s, less than 3d. What does this mean? It means that your 1s orbital is having the lowest energy. So electron first enters into 1s orbital, and once the 1s orbital gets filled, it will enter into 2s orbital. Once the 2s orbital gets filled, then it will enter into 2p, then 3s, then 3p, and so on. Once again I am repeating this Aufbau principle. Please try to focus again on this. Aufbau is basically a German word that means construction. Okay, now this principle basically states that electron first enters into the lowest energy orbital and then higher energy orbital gets filled gradually. So in that case he has given a order, that is, you can see here 1s orbital is having energy lower than 2s, 2s orbital is having energy lower than 2p, 2p orbital is having energy lower than 3s, 3s orbital is having energy lower than 3p, 3p orbital is having energy lower than 4s, 4s orbital is having energy lower than 3d. That is the meaning of this principle. Now we will try to put up Aufbau principle and another concept together into role, and we can make up the configuration of the different elements. One more table that one has to remember is so that table is having basically 3 columns, that is orbitals, fold degeneracy and maximum electron intake. We have calculated all the things earlier. We will just compile all the data. You are having S, P, D and F orbitals. S was having 1-fold degeneracy, P was having 3-fold degeneracy, D was having 5-fold degeneracy, F was having 7-fold degeneracy. Now if we want to find out the electron intake, simply multiply this degeneracy by 2, you will get how much maximum electrons it can intake. So if we multiply, we will get 2, we will get 6, we will get 10 and we will get 14. Okay, this is the thing one has to remember. Another thing, the same chart can be made up in case of your orbits also, that is, you can write here orbits, then shells and electron intake. So you have first, second, third, fourth. Similarly you can write here K shell, L shell,